Today, we're going to talk about operations with radicals, and these operations involve addition, subtraction, and multiplication today. So when we're looking at operations with radicals, it's kind of like combining like terms. So if you have any radicals that have the same number underneath the radical, you can go ahead and combine them. So we can see that these two have the same number underneath the radical. So we can add the numbers that are in front of the radical. So we can go ahead and add our -2 and our +3, which is -1, or +1 rather, actually, because 3 is a bigger number. And then we can drop down whatever does not have a like radical. We also want to check when we've combined like terms that neither of the radicals can simplify using a factor tree. So if you break down 6 into factors, 3 times 2 is 6. Since there's no pairs, you can't simplify this further. And same goes with 3. 3 times 1 is 3. So we're breaking it down into something we call a product of primes. And since there's no pairs, we actually stop our answer right here. So when we go into this one, we'll look for like terms again. We see that the 2√5, there's no like terms because nobody else has a radical 5. And we see that over here, these two can go together because they both have a radical 2. -3 and -2 added together is -5. And then we'll drop our radical 2. If it helps to highlight the numbers that are in front of the like term, you're welcome to. Once again, 5 and 2 cannot be broken down further because if we factor it down into a product of primes, so we're looking for numbers that 5 divides by and 2 divides by, and keep breaking it down, neither of these have pairs. So this would be your final answer. When we're looking at this one, we don't see any like terms to start. So what I'm going to do is either leave it here, or I can look and see if these break down any further. 5 is just 5 and 1 again, so we can leave it. Excuse me. 24, 4 times 6 is 24. So you can pick any numbers that multiply to 24. And then we're going to keep breaking it down. So like 2 times 2 is 4 and 3 times 2 is 6. So what we do is we look and we see if there's any pairs. So since there's a pair of 2's, what we can do is we can bring a singular 2 out front with this 2. So let's drag and drop this square root -5 because that one doesn't simplify. 5 and 1, there's no pairs. We're going to take this pair of 2's and you're going to bring it out one time and multiply it with the 2 that's already out here. And then the loners go on the inside and multiply together, which gives us 4 radical 6. And negative radical 5 stays. Over here, we can break this down to 4 and 5 and 2 and 2. So there's a pair of 2's that's going to come out with this -3. Like they're going out on a hot date. And then the lonely number stays on the inside of the radical. So we have a -6 radical 5. And now what we notice here is that we have like terms. So we have this one and this one. So if we take an invisible 1 out front, we have -1 and -6. That's -7. You're going to keep the radical 5. And then we're going to bring our 4 radical 6 down. So if you haven't done factor trees before, you're really just breaking down the number underneath the radical into something we call a product of primes. And keep breaking it down till it can't break down anymore. So there's no numbers that go into 2 and no numbers that go into 3. Every time you have a pair, it comes outside of the radical and multiplies with the outside number. So let's try one more with addition, and then we'll have a separate little video for multiplication. So here we have 9 and 5. That can break down to 3 and 3. So we have a pair of 3's going to come out here with this 3 and multiply. You only write the 3 once for each pair. This 3 was already here and the lonely stays inside. Here we have 4 and 3, and we have a pair of 2s because 4 breaks down into 2 and 2. A singular 2 will come out with that 3 and multiply, like they're going on a hot date. And our lonely number stays on the inside. We've already actually broken down this 45 before, so we could have combined those to start, but since we forgot to, AKA I did, we can break it down into 9 and 5, because 9 times 5 is 45, and 3 times 3 is 9. Once again, we have a little 3 that's going to come out and hang out with our other 3. And our lonely 5. This is 9 root 5, and this one coincidentally is the same. And this is 6 root 3. So we're just going to look through and see if we have any like terms that have the same radical. And simply take the number on the outside and add it together. So 9 plus 9 is 18. Root 5 stays the same. And then 6 root 3 drops down. And this is our final answer. So we can 100% just break down each one individually. Or if it would have been easier for you, you could have put these two together in the beginning. So the other way you could have done this is you could have, oh, that's a new pen. You could have put this one and this one together first, getting you a 6 root 45, and then add it to the 3 root 12. We would have then only had to break this down one time. So we still would have done the same process of 9 times 5 is 45, 3 times 3 is 9. The pair of 3s is going to kick it with the 6. You write it once, and you would actually get the same final answer of 18 root 5 plus 3 root 12. And I realized you would actually have to break down the 3 root 12 further, and that's how we got that 6 root 3. So just remembering that this would have to be broken down further, which I ran out of paper, but showing those two separate ways that you can do it. Me personally, I like to combine stuff in the beginning. It's a little easier, but sometimes it's easier for people to combine after. So just choose the way that works for you. And this is how we add and subtract radicals, and there'll be a separate video on how to multiply them.